Hi, I'm Tom Diafinianizegie from Skudar University, and today I'm excited to present my project, the AI-powered agriculture system. So this system is designed to help farmers make data-driven decisions using real-time sensor data, AI-powered disease detection, predictive analytics, and crop yield, and smart farming advice. And basically, here's the project, and from the front end I use React, and from the back end I use the Flask with AI models. And let's start with the front end. As you can see here, there is the front end, the React project, and as I was saying, here's the front end is built with React and TypeScript using Material UI as here. So first of all, let's review the front end. As you can see, I have I have some components. This is just the dashboard, and let me just walk through the components real quick. But first, let's go with the components. And so this is AI-powered AI-powered agriculture system, and with the React and Material UI, and this is like a solution including the React. So let's start with just the front end. As you can see here, what I'm displaying, this is sensor display. Okay, it displays real-time temperature, humidity, and soil moisture. Sorry, and it updates every 10 seconds automatically. Includes a clear icon, and here is the sensor child history. And as you can see here, this is just a component. And here I have another one called yield prediction. I have disease detection uploader, sensor displayer, sensor history chart, smart recommendation. Here's the sensor display again. As you can see here, for the sensor display, sensor displayer, it updates every 10 seconds automatically. This is just I used an API for the sensor display. And here's the disease detection uploader, and for disease detection uploader I use the user can drag and drop an image, and the AI will just analyze the image, and they give him a predicted disease, if there is a disease or if there is not. And there is also like a confidence score for trustworthiness, and also a real-time preview. And here's the sensor history chart, and this is just for visualization, to visualize the data and select the customer data ranges. And here's the yield prediction, which is simple form for like input like crop type area. Uses like a regression model to estimate the yield. And it depends on the country, city, and as a yield, as you can see, and use like regression model to estimate the yield, and also like the level of improvement, as you can see here. So I have also the smart recommendation. This is what I'm displaying. This is just for smart recommendation, which is like analyze the real-time data, and it offers like actionable tips like low soil moisture detected, and consider like irrigation and stuff. And it also update instantly as the new data arrives, which use like an external API. So let's just now check the backend real quick. So for the backend, here is the where the old API endpoint is managed, and the handle like request image uploader, AI model communication, like stuff like coordinate the data flow and the responses, and include like the cost and the security settings. And here's like this is a model which loads a CNN. CNN is just like a model. Yeah, I was training on tomatoes leaf disease, but it takes time to train it, because I use like to train it I can use like I was using OpenCV and Pillow, but like what I have now is just normalize and predict like upload image, in which you return like a class and confidential level, which is like a pretty simple implementation based on time, because like the training model we take time to be trained. So I make it pretty easy using download CNN model obviously. So I have also, as you can see here, I have also what's called it's for prediction. For the image for the model is just like give random number, yeah. And here is like the models, the models.py, which define the sensor data using obviously SQL RCAM, and it stores the timestamps and the sensor values, which is like easily extendable to include like the user specific data. So here is this is just a script for simulation IoT. What simulation IoT is just to test the system without like really sensors, which is like a Python based IoT simulation, but like it sends like random but realistic sensor data for like each 10 seconds, which simulates like temperature, humidity and soil moisture, obviously, which communicates with the endpoint like API data, the post API data, and you get the API data latest, which like also like post the predict disease. It also works with all of this, yeah, and which is like there is another endpoint called API recommendation. It's a get, not a post, and this just helps for validate like the whole system under real-time conditions. And here is the running process. So for running process, I have three stuff. I have the backend, I have the front end, I have also the script. So let me show you guys how I'm running it. First, yeah. So I have an environment in the backend. Just run the Python, the app, then go back to the front end. Now I can also run the script, the IoT simulation. So you will see just how seamless the components communicate is. As you can see up, there is fetching information. So here is just I'm gonna skip. This is gonna take time. So here's how all the parts come together. Here's the AI power agriculture dashboard. As you can see, there is the temperature, the humidity, and soil moistures. There is sensor data. There is crop yield. I'm gonna just test it right now. This is the crop yield prediction. Gives you prediction about the selected. Can select the country, the city, also the crop type, and also the season. It tells you like a message is just for prevention, or just tell you if you can plant or if you cannot. And you can even check like there is the recommendation. This is just an alert for this is gonna come like a notification, an alert for the irrigation alert, the temperature alert, or like optional condition. This is just easy. And there is like a sensor data history. There is disease detection, and there is also temperature, humidity, and soil moisture. And here is the sensor data history. As you can see, the right side it's fetching the real-time data from the outsider API integration I used, as I was saying before, which helps for practically everything. And yes, this is it. Thank you so much. My name is Don Diaf again.